Why do scientists make such a fuss about 1 or 2 degree increases in global average temperatures? Even at the equator, the temperature changes more each day. And in some places, the difference between night and day can be 30 degrees or more. So why all the alarm bells? To understand why, we need to look at global temperatures long term. We'll look first at the last million years, then the last 12,000 years, and then at the last 65 million years. Here you can see the last million years, and you can see that the average temperature for all this time was about 12.5 degrees centigrade. On the right at the bottom, you can see the end of the last ice age. And then the temperature was just over 9 degrees, more than 3 degrees lower than the long-term average. Over the following 10,000 years, the temperature gradually rose to about 14.5 degrees. And as you can see, this followed a pattern. Over the last million years, there have been long periods of warming, which lasted thousands of years, followed by long periods of cooling, which also lasted thousands of years. These changes are the result of small changes in the Earth's orbit around the Sun. The last 2,000 years is on the right at the top. The temperature was very high compared to the last million years. The last 2,000 years have been about 2 degrees warmer than the long-term average. Note that this chart doesn't show what's happened in the last 200 years. Now let's look at the last 12,000 years. This chart shows the last 12,000 years from the end of the last ice age to today. It shows how the temperature compares to the average in the 20th century. The thick black line is the average of all the academic studies. On the right, you can see the last 1,000 years, and there are two fluctuations marked on the graph. One, around 1,000 years ago, was the medieval warming period, when grapes grew in Scandinavia. This mostly affected the northern hemisphere, and global temperatures didn't change very much. There's also the Little Ice Age, the LIA, when the temperature fell. Multiple causes have been identified for this, with volcanic activity playing a very important role. What's happening today is completely different in both scale and speed. In the Little Ice Age, it took 400 years for the temperature to drop by 0.6 of a degree, and it took 200 years to recover. Over the last 200 years, the temperature has changed 3 times more in half the time, with the fastest change in the last 50 years. And all of this is because of people burning fossil fuels. To understand what will happen as the temperature rises further, we need to look even further back into the past. This chart shows the last 65 million years. And you can see, for example, that the temperature 65 million years ago was 10 degrees higher than the long-term average before the beginning of the 19th century. On the far left, there's a spike 45 million years ago. This may have been caused by an underwater volcanic eruption in the Indian Ocean, though we don't know for sure. What's important is that there was a sudden and very large spike in temperatures, just like now. Important too is that it took 40,000 years for the planet to correct that change. Now look at the far right of the chart, at the red arrow where the 2 dotted lines cross. That's the average global temperature in September 2023. It was 1.8 degrees above the pre-industrial average and far above the IPCC's projections, which suggests the world is getting hotter more quickly than expected. September 2023 had the highest average global temperature in more than 100,000 years. The last time the planet was consistently this hot was 3 million years ago. On the far right of the chart are the IPCC's projections for the remainder of the century. At the upper end of this forecast, which is consistent with current trends, the average temperature on the planet in 2100 will be exactly as it was 40 million years ago. 40 million years ago, there wasn't much life on Earth, and there was no ice. Of course, the planet will take centuries to get back to how it was then. But that's what will happen unless there's a serious effort to change. We need to cut all fossil fuel use and change the way we grow food to stop using fertilizers. Of course, that will cause enormous economic disruption, but awful as that will be, it would be better than carrying on like now.